Keep your eye on the ions. So to begin, I'm going to play a demonstration here that is showing us the formation of a couple of solutions, and then it's also going to show us how they react together. So to begin here, we have two compounds that are represented here. So this is going to be silver nitrate, and the other one represents sodium chloride. So these are representing solids right now. And this little piece of paper is being used to indicate that there's a bond between them. So now we're going to drop these into water. So we've changed it from solid, now we have aqueous. So if we look, we see that those ions, we have silver and nitrate there, and sodium and chlorine here, those ions have separated in solution. So they are now aqueous solutions. Now I'm going to take these two solutions and I'm going to mix them together into this beaker here. So I'm pouring in my sodium chloride and my silver nitrate. And when these react together, notice that there's two spheres that are still just floating around in the water. But then two of these have sunk to the bottom and they've stuck together. So this is what we call a precipitate. It's when a solid forms upon two solutions reacting together. So we want to draw a diagram for each of the compounds. So here we have silver nitrate. That's going to be the yellow and black. And then we have sodium chloride, which is blue and orange. So right now, these both represent solid. The little slips of paper shown here as these gray rectangles, those represent the ionic bonds that are holding together those ions. So holding together silver and nitrate, and then the bonds holding together sodium and chloride. Next, we took those two solids and we added them to the beaker. And when we did, we saw that the ions broke apart, they separated from each other in solution. So now we have silver nitrate aqueous and sodium chloride aqueous as well here. So we've just formed these solutions here by dissolving. Now we combined those two solutions together. So we saw that we formed a new compound here. This is a double replacement reaction. We formed a new compound and it sunk to the bottom and formed a solid. And we still have some ions that are just floating around in solution here. So to compare where we started from, we see that we have silver nitrate solid and sodium chloride solid. So we can see that we have some of those ions, the black and the blue, are just floating around in solution. They didn't actually react, whereas the orange and the yellow, they did react and formed a new compound, which sunk to the bottom of the beaker as a solid. So use picture 1b to explain what happens when the compounds are first added to water, forming solutions. So they were dissolving. We were breaking those ionic bonds, changing the solid ionic compounds into aqueous ionic compounds. So which of the colored balls represented the precipitate? Those are the ones that sunk to the bottom, the yellow and the orange. Those stuck together and sunk to the bottom, representing the solid formed from this reaction. So now we want to try to write out a chemical equation that describes this reaction here. So we're going to start with silver nitrate. Silver is a metal, and its charge whenever it forms an ionic compound is always +1. Nitrate is a polyatomic ion with a charge of -1. So since we have +1 and -1 here, those charges work, and the formula is just AgNO3. And it says that it is aqueous. So we don't need these charges anymore because we know that AgNO3 is the correct formula. Okay, this is going to react with sodium chloride. Sodium has a +1 charge and chloride has a -1 charge. So my formula is just AgCl. I need 1 sodium for each chlorine so that the charge adds up to 0. And we are going to produce silver chloride. Silver being +1, chloride being -1, so that works. And we're going to produce sodium nitrate. Sodium is +1, nitrate is -1, so those charges work as well. So we saw in the reaction here that we formed a solid in the bottom of the beaker. So which of these is going to be our solid? So to figure that out, we're going to use our solubility rules. So for sodium nitrate, nitrates are always aqueous and there's no exceptions. So this is going to be the black and blue spheres. Whereas silver chloride, chlorides are usually soluble, but silver is one of the exceptions when they are not. So we now have a chemical equation here. We can check to see if it's balanced. So I see 1 silver, 1 nitrate, 1 sodium, 1 chlorine. On the other side, 1 silver, 1 chlorine, 1 sodium, 1 nitrate. It's already balanced. So here is the chemical equation that we get to represent the reaction that we just demonstrated with those colored spheres.